fuck up.
Who will?
Hello everyone, and welcome to another episode of Endgame with your hosts Poplopo and Freeman. If you're a zombie, this will be an interesting topic for you. Today we're talking about neural interfaces. Now, hold on to your brains and to your neighbors. Take it away, guys.
Well, hey, Taro, thank you very much for that great introduction. And hello, everybody. Welcome to Endgame. We are a talk show about the future of humanity. And tonight our topic is on neural interfaces. If you don't know what that is, we'll go into that a little bit. I am joined here tonight with Freeman. If you've been to Endgame before, you've definitely seen him around. He is an active participant in all our conversations, and he's been helping me do research on this topic and was kind enough to join me tonight in presenting. So thanks for joining me on stage. All right, so so we're talking about neural interfaces. Do you have like a quick definition of what that is?
Well, I mean, there's a lot of scientific definitions, but what I found the easiest way to describe it, the easiest way that I understand, because I'm not that good at science myself. It's basically getting computers to understand it's mind reading. Computers can read our minds, and the computers can almost broadcast back thoughts into our minds.
Now that sounds a little fantastical. But I like it. I think that's accurate. If you think about
you've got
interfaces,
the scientific way.
Well, not exactly. I mean, I don't know. I've got the programmer's way, right? So like an interface is an intermediary layer between you and something else. And in this case, it's between a person's brain and some machine. But there's interfaces everywhere that right now, our VR headset and VR chat is the interface between us and each other. Like a keyboard and a mouse is like the interface between you and the computer. So a neural interface would be, something that accepts input from your brain.
So, dig this. I'm about to show my dad VR, and I'm super
we're in the middle
duper
of the show, dude. Okay, and that has a couple of different forms, and like mind reading is kind of the more obvious one, where you can like think something and then it'll happen in the whatever, if for the machine or whatever it is. Kind of start off a little bit. We're kind of talk about like the more like realistic sort of current version of things. Which, can everyone see this? It's a guy wearing an EEG, and there's like brain wave lines. Really?
No. Oh
No.
oh.
Oh man. So you
it's
need
an
to
EEG
rejoin.
for me.
You need to rejoin the
Question and a
instance
breath test for me.
because you're in the
rejoin?
previous.
Half and half.
Oh,
I'm sorry.
okay.
I've been
I'm so
meaning
sorry.
I've been meaning to get this out because I really want to say it. When it comes to neural interfacing, it's about being able to create the layouts to be able to translate the communication between the brain and another object, which of course has to do with electronics and everything. But
it sounds like you have a lot of. It sounds like you have a lot of good information, and I really want to hear it. But you gotta wait till we call on you. And I was sort of in the middle of figuring out another problem.
Sorry, it was bottling up. Thanks.
Don't worry. Like, look, our whole show will be about this. Like, we definitely want to talk to you about it if you know anything about it.
Right,
but
thanks.
okay, so some people here can't see this, so I'm gonna open up a portal, and you guys are gonna go through it, and hopefully that will work. Did we ever stop being live? Okay, so we have audio. All right. Sorry about that. If you're watching the stream, having some technical difficulties, that it's invalidating caches and naming things are the two difficult parts of programming, and we've ran into the first one of those today. Okay. Talking about neural interfaces. The basic component of the neural interfaces that exist presently, Igrium, you are breathing into your mic, is the electroencephalogram, which is this cool device. It wraps all around your head, and this is what medical professionals use to read your brain waves. So just on a physical, biological level, your brain is sending electronic impulses through your nervous system all the time, and those electronic impulses are generating brain waves. And so devices like this receive those brain waves and basically transform them into data like this. They measure them, essentially. They measure wavelength and frequency, and from that, they can get kind of a picture of the activity of your brain, which we'll see even more interesting pictures later on. But Vessel Unit, you had some stuff to say about neural interfaces. Why don't you go ahead and say that again?
All right, thanks for inviting me up.
Well, you stay in the center. The camera is right here. I don't know if you can see it.
Sorry. All right. So I did a little bit of digging into neural stuff. I mean, I'm not gonna say I'm any professional or actually know what the hell I'm talking about. I'm an amateur. But the way I see it is the fact that when it comes to the brain and interfacing in general.
I have a question. What do you mean by digging into?
Okay, I basically did a whole week's of binging research into it across multiple
what do you mean
sources.
by research into it? Were you writing code or?
Dude, just let him talk.
I think it's pretty obvious that.
Just trying to get some context.
Let him speak first, sir.
Okay,
I
take into context.
So rude.
both.
I'm so sorry.
Yeah, no, it's fine. It's actually fine that you bring that up because programming actually does have to do with things in the brain, because I do like to treat things like things work similarly to a computer. But overall, though, with interfacing with neural things, it's like interfacing with a USB drive. You have the device, and sometimes it works differently. It has a different structure, and you have to have something to translate it. The two different to actually work as an interpreter between the two, where one interprets one thing one way and to the other way. So it's a two-way gate, and it allows for that communication and sends signals to each other. And that's how the interface works. It works as a layout for the brain to interact with the item that it's supposed to interact with.
To illustrate that a little bit, these signals that the EEG picks up, they don't do anything on their own. You have to have a receiving device that you've programmed to interpret these in some way and do something with them. Kat, you got a comment?
Yeah. So how I'm reading this is kind of like you have a USB, but you need a USB swatch to get the information onto the computer. Is that what it's like?
Yeah, that's
basically
a good comparison.
It's okay. It's like imagine this: you have a bunch of wires hooked up between your brain and a computer, and it kind of records data of your brain, like wavelengths and heat and everything. It's like how you have machines that record things to our bodies. We're hooked up to them, and it interprets what we're going through, like our heat, our heart pulse, and it translates the information from imagine sonars. You feel the pulse, right? That impact would translate into those beeps that you would hear in the computer. That's just one example of translating it from one place to another.
Yes.
Can I just add a small comment?
On a very basic level, yes, that is a good comparison. Pizza Life?
Just a small comment. Yeah, I mean, isn't also one of the things with if what you're measuring is what you're measuring. We're measuring this 2D signal that we're putting in various parts of the brain. That's what we're getting because that's what we're measuring. Maybe the brain operates in a slightly higher dimension than that,
It's entirely possible, and I think as we continue to do research on neural interfacing, we're gonna find that out, and that will be a very exciting thing.
I think the biggest problem with human interfacing, with neural interfacing, the worst part about it, is the
Okay,
fact
one
that you
last
have to
comment,
make the
and then we're gonna
technology
continue.
extremely versatile to be able to calibrate itself to each brain, because every brain is different
Right.
from one another, and in order to get the interface to work naturally for each one of them, you have to have that calibration, and it's so much of a hassle.
And that kind of has to do with that too, where like each human brain operates at least a little differently. Like we've all got brain waves, but you can't. As far as I know, we don't have the ability yet to reverse to take a signal and then reverse engineer and figure out what's happening inside that signal. So
And it's also
there-
the positions of where
It's all
certain
very
spots of
loose
the brain
right now.
react with certain things.
Sure. Yes. Okay. Thank you, Vessel Unit. We're gonna keep going.
Thank you very much.
All right. So this is the basic technology that we have right now, and this is what our medical field is using to analyze their patients. But it's starting to get into the mainstream just a little bit. So these are the emotive products. It's like a specific brand of neural headset, and this is marketed towards a few different types of groups. So like this is a more expensive one for $800, which is actually really, really cheap. Like one of those like medical EEGs is like thousands of dollars, and it has more fidelity and is more like scientifically like significant. It produces more scientifically significant data. But this is available also for people who are doing research. And then there's even mobile versions. There's a couple of these out that just wrap around your head, and like they don't have the same type of electrodes, so the fidelity of their signals that they're receiving is not as accurate, but it's still enough to it's still enough to actually make things happen. Have you guys heard of the game? What's it called? Throw trucks with your mind.
What?
It's a game.
Sounds fun.
It was a Kickstarter project, and it was this guy who literally he wrote an app that for a neural interface device that very similar to this that you wear on your head, and then you focus on an object in the game, and it would lift it up, and it's a multiplayer game, so you get more than one person playing this game wearing these headsets, and then you can get if you focus on a particular object, it pays attention to what you're looking at and your level of focus going on in your brain. And if you focus enough, it'll lift up the truck, and then you can use it to like throw it at your friend. And so it's like a competitive game.
So you get to be
like-
telepathic.
Yeah. And actually these games are like all over the place. I kept coming across them a lot while I was doing research. And you did too, right, Freeman?
Yeah, I mean, I found one by some studio where they literally made a game where you're a telepathic guy. So it was like you look at stuff and then you can throw stuff and turn them into like sausages and stuff. It's kind of weird. And we will throw some
Yeah.
links out after this. You gotta look at them. It's kind of crazy.
Right, yes. We will send some links to the Discord. Pika Petey, you got a comment?
Yeah, do all these require like that gel that a lot of physical shock therapy pads use?
No, this one
Like
one does.
ultrasound and stuff. Yeah, it's kind of
Yeah,
Yeah, like that
some of them-
ultrasound gel. Because I
Yeah.
know a
Some
lot
of
of
them
times
do.
with higher cranium stuff, you have to
That's
like almost
conductive
shave the
gel.
scalp.
Right.
I don't think
And
a lot
that
of
would be
That's
that would
just
be
one of
sort
the
of like
multiple methods, and honestly, it is one way to work.
okay.
But
I was
it's like-
wondering.
What I've seen,
something like this
no.
wouldn't. Yeah.
From what I've seen,
this
you
one-
don't need it.
This one literally is that what you described. It says there's a gel. You apply gel to your head, and that gives you a better connection.
Yeah, those. Okay.
But you know, in the future, when we're all just like dipped into vats of acid to be in VR, you know, that gel will really come in handy.
Just gonna rub
Yeah, I mean, we'll
shampoo
be
on
in
my
the
head to get
Matrix
a
at one
VR.
point or the other. So
We're being batteries for the robots, right?
Exactly,
Yeah, I think
exactly.
that's how that goes.
got that right.
Definitely. Agreed.
So, the telepathy game kind of got me thinking. Do these little headsets that you wear? I can't really tell by the picture how you actually put them on. Could you wear them with a VR headset on at the same time?
Well, I'm not sure about these particular models, but I guarantee you, like, that will be a thing in the future. You got something to say,
Or if they
Ghoster?
combine them together.
So, I've actually got a thing for you. Yes. Well, they're not specifically to be designed to be worn with headsets. They can be, because there's another game that's not this one that actually just came out with support for these sensors here. The specifically the Epoch. I don't know if the Insight was actually supported, but they do have the EEG support, and you can output the raw data from that and control different things. So, like, let's say I'm concentrating really
This is a
hard and I want to
VR
be
game?
angry. Yeah, it's called Neos VR.
Wait,
Wait,
Neos
so
VR integrated
could-
neural devices into their.
Wait, so you could like, if you actually start like feeling happy or laughing, like your character could like
It could,
lighten
or
up.
you could link it to the
Emotions.
lights of the world, so that you could show, oh, hey, look, that guy's got a
Emotions.
bright blue light because he's really happy, or he's got a dark red
Yeah.
light because he's angry, something like that. If you
So
get the
the
calculations
Neos
correct.
devs, the Neos devs are crazy in a good
Dev.
way. We should talk more about Neos on this
Yeah.
on
Dev.
this
The
show.
one thing I have learned in the course
An
of
emotion
doing
light.
like film and stuff like that is
A mood
everything
ring.
like human about someone is in the face. Like if your face is static, like my avatar is right now because I'm not finished with it, you're gonna have a hard time relating to a character, or in this case, another person. So if you can get the face kind of contracting and animating in a way that is concurrent with someone's actual emotional state, it's going to be so much easier to socialize and empathize with them. And that's only the beginning of what you could do with this stuff. And that's assuming you go this route instead of like having to like implement facial tracking of some sort, which would also probably work. But you
Pika
could
is
also
trying really hard to get your attention with his facial.
Yeah,
expressions.
I know exactly what he's going to say though.
but,
I'm sorry, I
you could
just had
also
to.
do a game where like you play
know-
like someone with telepathy who's like escaping from a science facility or something like that where they've been experimented on, and you actually like use your mind to try to like move things and fight people. So that would
sounds
be
like
really
a super fun
interesting.
game. I like
So,
that idea a lot, and it seems totally within the realm of possibility. To go to the next slide, this is a this is from a presentation from JSConf in 2018, and this is Charlie Gerard. She's a researcher, and she purchased this is one of the emotive headsets, and she literally this is a game, or like a game. It's a virtual environment, written in JavaScript actually, that she can control the camera with her mind. So when she thinks to the camera, okay, turn right, the camera will turn right and rotate right, and she thinks left, the camera will rotate left. And so she presented this stuff, and like she's just one person writing like a little node server, and you know, with a bit of cash for the research devices, and she was able to do, you know, basically mind control interfacing. There's this other stuff here, buttons here, where like it has her facial expression, it has the mental command she's trying to do, and like I don't know what other type of information you can get, but like it's pretty impressive for just one person to be able to do that. And so I think probably we're moving pretty quickly. All right,
have a
Vessel.
video.
All
Not
right,
of this
so
one. I'll link it to you.
So for one thing with this hardware, if the person is thinking about looking left, but
Thing is, though, is that's
I can see that there's clearly those handles and everything. Are they still going to be moving around their arms?
She did not move around her arms, but she.
Okay,
I mean,
so you just attach it to your arms and it will feel the signal from your hands, and it'll actually move your hands in the game without actually moving your arms in reality.
So you could do that, but like she just hooked it up to her head. Like that was the only signal.
Yeah,
But you're right.
yeah.
Like with because your nervous system is not just in your brain. Your nervous system extends throughout your entire body. So depending on how extensive the device is that you're using, you could use your entire body as a video game controller, in a different way than we do in VR, like in a much more intimate way, really.
I just wanted to make sure on that fact, because if you have the ability to turn your head without actually turning your head, but then you still have to move your arms around manually, it would feel really weird and make you kind of disconnected.
Yeah, well, I mean, this wasn't a VR. This wasn't a VR game by any
Yeah,
means. It was just
yeah.
a screen. But yes, you're
It's
right.
just more of interface. The reason why I wanted to check it out, see if that would work.
I mean, it would do wonders for people with ALS.
Yes, there are a lot of potentials out there for medical uses. We've got some other people, so I'm gonna go to the next
I have
person.
one last point to bring up.
All right.
If we were to have a VR where you have everything, whereas not only transmitting information from our bodies to do what is in there, but to also receive information such as feeling and neural placement and everything, such as nerves and everything. Now, imagine this. You have the whole VR set up where you can do everything and feel everything that happens in the world. But then imagine if the world was also still full of user-generated content. And you know how much people can mess things up for each other because of how many possibilities of flaws there are? There could be less collisions, or people would have too many collisions. It could have the wrong hitboxes, and it would cause a lot of problems for a lot of experiences. And that's why I think it's very fragile.
Yeah, you know, I guess it all depends on how you set it up.
Yeah, and that's why I'm scared about the restrictions of future VR if it were to go better and to go farther into our nervous system. Because they will.
Yeah, I mean, hold that thought.
They will
hold that thought, because we'll come on to the ethics of this kind of technology in a bit. So
hold on. Freeman was talking. What were you saying?
No, hold that thought, because we'll come on to the ethics of this kind of technology, especially with VR and, you know, with all of this, really. So, you know, hold that thought. You know, we'll come back to this. Don't worry.
Yeah, we'll keep moving.
I'll get off now.
Thank you.
Thank you for letting me speak.
Hello. So don't get me wrong, I'm young, so I don't really know as much as you guys probably would, but I had an idea back, I want to say about a year ago, where it's kind of like what he was just talking about, only a little different. I'm not going to go into specifics because I had this thing all planned out, but my thought was you would have a device and there would be a main server, and it would basically send thought waves back and forth to kind of update a picture in your head almost. Almost like, so basically while you're dreaming, it could kind of control your dream, and while your mind was connected to a central server, it's basically SAO to sum it up.
So
yeah, I mean, that sounds amazing.
So you have a client side and a server side, which they're both.
Hold on.
Yeah, pretty much. Exactly.
Yeah, I mean, it's a good idea, but I think the fundamental thing that we all agree is, you know, in terms of that, it's the latency, isn't it? It's like there's always going to be like lag between some sort of faraway server. I mean, unless you're directly connected to your own PC. I mean, this is why, you know, we've got, you know, Google Stadia and all that. At the end of the day, that's never going to work for VR, is it? You know, they tout all this amazing low latency, but it's never going to work for us.
The speed that we need VR able to operate at, like the latency we need, like that wasn't possible, you know, 2 decades ago, like that, you know, and now we can do it, and we can get whatever ridiculous refresh rate we have in our headsets, and you know, I don't know, it could be possible.
I don't know. I mean, I think it's fundamental. We're limited by the speed of light, but I mean that is our limiting factor, isn't it? So I mean,
but that's the limiting factor in our brains too. Like we can't, you know, like we can't. Our brains also can't operate faster than the speed of light. So if you've got some sort of light-based, what's that called? Optic connection between your device and your server device, and it's, you know, like populated. But another thing too is that we don't currently, and unless I just haven't found it yet, we don't know how to input signals into the brain like that.
Yeah.
We can actually retrieve them, and there have been studies done where people will look at a screen, and through their generated brain waves, others can piece together what image they're looking at. So they're like that information we can kind of extract from the brain a little bit when it comes to visual stimulus, but we don't currently know how to induce visual stimulus quite in that way. Although,
Yeah, I mean, the scary thing is, the only
It
known
does.
way is to hijack our current ways of getting information to the brain. So,
that's scary.
yeah.
Oh, yeah,
Anyway.
that was actually going to be my point. Because you've shown us in an attempt to move this lecture along, you have a lot of evidence of like output stimulus, but is there any evidence in input stimulus? Like, has any probing of the brain, like brain mapping? I know they do that in neural surgery. Has it produced any like quantifiable results? Like, has there been any study on that, like input?
Well, there's no. I think it's like what we know is that there's no one map of the human brain that you could use to interpret any individual's brain. Like every brain has its own thought patterns. Like every brain has its own internal like electrical activity that correspond to memories and emotions and thoughts. So even if you are able to, but you can do
Generalized brain structures, mostly.
well, I mean, you can. So you can see, okay, someone's hippocampus is activated, someone's neocortex is activated. Like you can see that kind of stuff, but it doesn't tell you what the person is thinking.
Yeah, I mean, fundamentally, no. Because, every brain's different. Yeah, you know which part of the brain gets activated, but yeah, he's feeling this bit, but you don't know what exactly he's feeling, especially, in certain parts of the brain where it's like memory-based or stuff like that. So, I mean, it's got to be analyzed by, it's got to be some sort of machine AI learning, it's got to be to analyze every brain that you have.
The device would have to be highly tuned to an individual, and you can do that, and that sort of thing is happening. Agram and catapult. Not yet. No, not yet.
Were you gonna say something?
This is just another example of a device out there. This device is available for $99, and there's an app store that goes with it that you can literally play video games with your brain for $100 plus the app. So
I mean, I've always wanted earrings too, so it's good.
Yeah, so that's out there. That's
Forget if that's like a grounding point.
But I haven't seen these slides, by the way.
Wait, hold on. Is that the
new
Android
app
one
box.
I've heard about, or is that actually connected to the computer?
No, this is the NeuroSky Mindwave. I don't know. It looks like it's maybe connected to a computer. I'm not entirely sure.
I'm gonna go do a quick bit of research on it. Thanks for telling me the name.
Okay. All right, Adrian.
So, damn it, I forgot the last name of the person we're going to talk about now. Let me quickly. Okay, sorry about that. Tilly Lockie is a amputee. Lost both her arms at birth. Very unfortunate. But they've been doing these experiments with robotic limbs, and they successfully made one where, like, if she articulates her fingers, then it kind of like picks up on what she was intending on doing and does that with the robotic hand and gives her feedback about what she feels like she's touching. Which I just wanted to throw that out there, and it's really interesting.
I like that. Thank you for that information. Yes, this is a I was mentioning before, like, this is kind of like a minor industry, and it already has a lot of medical and therapeutic use cases that people are already using, and that kind of thing is very exciting.
It picked up on electrodes on her hand, though, not her brain.
Okay, well, I mean, that's cool.
She lost her hand.
Actually, that's one thing I also wanted to bring up. For the most accurate way of interfacing between a human body and to the virtual space is to have a connection between both the brain and the spine connected to the client. Because the spine is actually where you'll get the best way to actually get that signal to each body part, rather than the brain and having to constantly dig around it. It's just the easiest possible way. The unfortunate part is the fact that it requires access to your spine.
Sure, yeah, that's problematic.
I don't know nothing about biology, so.
Well, all of this is so much in its infancy that we haven't even scratched the primer coat, let alone the surface yet. But like example, person that was crippled in an accident or something, whether it was spinal cord damage or nerve damage, they manage on putting electrodes and getting the muscles that are supposedly dead or, disconnected. And they put in some electrical impulse. All of a sudden, the muscles start twitching, and they can figure a way of making those muscles move certain ways to the point where this person can walk again, even though it's not a natural walk, but they can walk again.
Yeah, that's super cool. Are you?
But then, like I say, that's just
imitating an unnatural walk.
It's kind of like
You look like the Google bot that learned how to walk on its own.
once they understand how all this stuff works, then it's just a matter of getting in upstairs and being able to project images and so on and so forth. Perfect example, Star Trek Next Generation, Geordie Forge with the two little probes on the side of his head, and he has the visor. Those probes could be hooked up to a computer and, bang, all of a sudden, you don't need eyes.
Perfect timing, because this slide is about a visual cortical prosthetic that I think exists, right, Freeman? Like this is not just conceptual, right? Like people have this, or is it?
I mean,
are you doing
it's
research on
like
it?
someone's had this. It's like
Yeah.
I think the first example or
So
something like this.
it has a digital camera, and it connects. Essentially, you have a implant that connects to your visual cortex, which is at the back of your head. And basically, if you're blind, the camera can send the signals from the camera to the visual cortex and stimulate basically your sense of sight without. Yeah, Igriam, you're breathing again. Stop it.
Someone had to tell me.
Anyway, so you can get visual signals from that. Am I remembering that correctly?
It's rudimentary stimulus. I mean, we're not talking about 4K camera in your eyeball. It's literally like just imagine you squint your eye and it's really blurry kind of thing, but it's still better than what he had before.
Still sounds
kind of
great
thing.
than
It's
being blind.
I mean, it's better than what he had before, but we're not talking about cyborg eyes. You can Deadshot or something like this from the films. Nothing like this.
As soon as this gets better than the human eye is, will people be getting this voluntarily?
Yeah, I mean that goes on to the ethics, what will happen in the future,
Yeah. Yeah. Do you have a comment?
Yeah. So, since we're on this slide, I'm gonna make what I was gonna say quick. But what I was gonna say is I've heard of these prosthetics that people have, and I don't remember. I think it was you who said it. And basically, that one was based off of muscle, but this one, it's connected to the person's arm, but it actually does read brain waves to see, okay, if they want to move their arm, then they use their mind to move the arm. And I think
I've seen something like that. Yeah, actually, if your nerve endings are dead in your arm, you can remap some of your nerve endings elsewhere in your body to be able to operate. You literally connect the muscles to different nerves or to different neurons, and there's something like that. I don't know if it's the same thing you're talking about.
I don't think that's quite it, but what it is if I grab the glass of water, my arm would reach out with my prosthetic, my robotic
Oh yeah, I think
arm,
I've seen this. Yeah.
And it would go and reach out and grab the glass. And also
I think I've seen that.
Also, I've heard about these. I'm pretty sure they're in their infancy, but from the one I saw, it kind of takes in kind of sound waves and kind of displays it as a black and white picture. So it's kind of like echo.
Yeah.
It kind of maps out the area you're in by using sound, and like echolocation, it sends it back to you as a black and white picture.
Yeah, you got it. You got it right there. I mean, it's very rudimentary.
Yeah.
It's not high fidelity. It's low fidelity, but it tells you where things are, kind of thing.
But
Yeah. So I think that's exactly what it is. Yeah.
Oh, nice.
Yeah. Yeah,
That's
and
pretty
then it
much it. Yeah.
sends it as a picture to your eyes.
Yeah. I mean, you can't. I mean, it's hard. I mean, like everybody said before, you know, it's really hard to translate what we see and send it to the brain. You know, that's the hardest thing. It's crack, isn't it? You know, so what can you send? You just send something and hope it works, kind of right now, at
Well,
least.
your brain is very adaptive, so it's going to learn how to interpret all sorts of different signals. All right, agree?
When you say that you can kind of like just like if we had the technology to stimulate the visual cortex to see things that your eyes aren't seeing, you have to wonder, could you make a VR headset that takes advantage of that? Could you take the rendered view from the game engine and hopefully still using existing interfaces like Steam VR and OpenVR? Could you possibly like
just beam it
just
straight to your
bypass the
head?
big bulky headset itself and send it right to your brain? And that's
I think so.
one of the.
I think that's.
I mean,
one
that's
of the
the holy
directions they're
grail, isn't
headed.
it? That's it.
Yeah.
I mean, who needs a VR headset?
Yeah,
All
You just
right.
sit
but there's
there
also like
and you're done.
there'd be no
Plug
screen door
in.
effect because there'd be like no
That sounds great.
issue. There'd be like no. I mean, there'd still be individual pixels, but like your eye has individual pixels that
Yeah,
it's like it's the cones and rods, but yet you don't see those individual pixels. Your brain just ignores them. Meanwhile,
Yeah,
it's
let
still
me stop you
possible to
there.
focus.
Don't worry, we're gonna come. We're gonna go on to that. Don't worry.
Okay.
Wait.
Yeah,
I have an important
but-
question though.
and-
How do you close your eyes in that situation?
Well, you just close your eyes. Surely, it's easy.
close your
Just go
eyes.
like this.
Use your
Close
muscle
your
memory.
Dude, they don't see you if you don't see them.
Also,
But
like
it's in your
when it
brain.
comes to like making VR more immersive, like there's other
Well,
stuff
The
you can do.
neurons
Like,
that control the muscles.
some of you like may know of the experiment where
Ah,
like
minor
someone was
detail.
able to figure out if someone was looking at them or not from like a distance away without looking, and I actually successfully recreated that experiment with my friends. It was really trippy, but you have to wonder, does everyone know what I'm talking about? The one where like you kind of have a sense if someone's looking at you. And one thing I've noticed is that like I still haven't actually done any like conclusive like experiments about this, but like that I don't feel that same kind of like presence that like someone's like looking at you or something like that when in VR.
Okay,
Like,
I'm
if I
sorry.
were on
I'm
a
gonna
stage
have
right
to stop
now-
you there. You know, I love your stories, but I think the show's getting a bit long. So
Yes,
Okay.
You make an interesting point. We don't have as much fidelity in VR as we do in real life, including whatever else might be going on in terms of signals that we're sending to each other. So yes, but we are going to continue. Thanks, Freeman. And
I have one
Vessel,
short joke to make.
before we get to you, I'm going to continue with this video.
We got 10 minutes left.
So
Okay,
well,
imagine
his-
FOV sliders.
I'm saying. Anyway.
Oh, like a big one. That sounds great. Okay, so regarding medical technology, and hopefully this works, I wanted to show you guys this. Hopefully it is gonna work. No, please work, please. No.
Squeeze it harder.
Ah! Okay, I can't. Okay, it's just
That's unfortunate.
not gonna work for some reason.
Okay.
Well, we've got a
Skip it.
still image. I'll send the link out to the video, but basically, something that they did where they were able to see this light in the brain. This is captured in real time. Basically, they took an MRI of someone's brain, and they built like a transparent 3D model of it, and then they attached an EEG to the same person and recorded or basically streamed the electrical signals coming from the EEG, and they were able to basically visualize the electrical signals that were traveling through the brain. It's super duper impressive when you can actually see the video. So that sucks that it just isn't working. I only got the slideshow
Same.
working. I don't understand.
Okay. Well, join the Discord and you can get the
Yeah, I'll
link.
send the link out. It's super cool. Sorry. That's really frustrating. Okay, so Freeman,
okay.
you brought up Black Mirror.
Okay, let's move on to
and-
the like the ethics. Like people, you guys were saying, what would happen?
Green
I
space
don't know.
shaders.
It's Steam start. Oh my god,
Like,
my lamp again now. Well,
what's the problem?
yeah, I mean, think about it. You know, you have things that can, you know, basically reach. I mean, we're talking about even now, you know, we have, you know, issues of privacy. You know, everyone's thinking, you know, oh, you know, everything you use, everyone can touch. You know, well, at the end of the day, everything that you know you're going to use to that will be able to interface is made by, you know, a company, and
So
and the
just
only way.
just to
Okay,
illustrate,
for
these are
context, yeah,
from
these are
Black
from the show
Mirror.
Black Mirror. It you know, has
this
anyone here
one-
seen Black Mirror? You know?
No.
Yeah.
In this one, he had a visual implant that basically recorded everything he saw. In this one, they have mapped someone's brain to
Consciousness,
basically consciousness to like build an artificial intelligence that they essentially like enslave. I don't know how far away we might be kind of far away from that one, but still, like they mapped someone's consciousness and then made another being out of it. And then this one is about a neural interface where he is playing a game in neural VR, basically, and it completely drives him insane and then kills him. Spoiler alert.
Yeah.
Sorry.
So, yeah, I mean, these things are obviously going to happen, obviously, but
I definitely.
you know, I mean,
yeah.
But more realistically, you know, things like data, you know, everything you think is absorbed by some computer. I mean, how are they going to make these interfaces suit your brain? Well, they're going to have to map your brain, like we talked about earlier. It's not easy to map a human brain. So, you know, you're not you're going to use your home PC to map your brain. No, it's going to be done by some ridiculously massive server farm somewhere in the world. But who's going to own that? Who's going to own your brain data? Can't they just use your brain data to recreate you as like a site, like some sort of, you know, robot slave somewhere, like a second consciousness?
Extreme targeted advertising.
That very extreme, yes.
Well, that's it. I mean, what's the best way like Facebook can ever advertise to you? Well, there you go.
I dreamed about this product, and the next day I wanted to buy it.
I mean, time to buy shares, mate. Once they figure this out.
Isn't that from
But anyway,
Futurama? Like, I forget it was like the first episode.
the thing is,
I mean,
yeah, I mean, the thing is, lots of these concepts are like everybody's thought of these before, but you know, back in I would say 10 years ago, you probably thought they, you know, yeah, they were crazy. But I mean,
So here, I have
yeah,
a
some of
question.
these are
in my head.
Yeah.
So I have a question. Does anybody have any ideas for solutions to the ethical concerns and privacy concerns?
Instead of centralizing everything by a massive server farm, try to do it locally on the PC and figure out how to do that.
Okay. Leslie, you got one?
Yeah.
Okay, so whenever I thought of ethics earlier, it was more about imagine crashes in VR chat, except they'll do shit to you if you were actually like if you actually had senses in the virtual space.
Yeah.
It would really hurt a lot to have people who will do shit to people like that. It would be very harmful. But then the second one, too, as a response to what you guys were talking about, I always just imagine, like, whenever you get, like, this VR thing, virtual reality thing set up in your brain and everything, not that it's really collecting much of brain data. I mean, that's not what I'm worried about, to be honest, but I'm pretty sure that might be the case. But I always imagine, like, those guys that, like, installs Wi-Fi routers into the houses and sets up the wires to the freaking outside. It's like, imagine that kind of scenario where that shit happens.
I mean, the thing is, I mean, it's a new technology that we cannot fathom right now. So, I mean, I get everything you say is true because, you know, you never know what people is going to set up. That's the crazy
Not
thing.
that it's true, but it is plausible.
Well,
yeah, plausible, definitely.
The problem with cybersecurity at all is that, like, tech moves faster than the laws can and defenses can. And, like, that's, like, a pattern we keep seeing over and over and over again.
You can't stop tech, but governments will always try and slow down in, like, you know, they're always slogged down by bureaucracy, aren't they? So
we're living in a time of change, and the governments are struggling to keep up.
They certainly are, yes.
100%.
Yeah, I'm kind of apolitical. I can't say anything about this.
Ghoster?
So I just want to make the quick comment of the main thing that you have to worry about, honestly, is going to be, do you know with the input methods that might be specified for the ethics question here of can you input in data into your brain? Are you in control of that, or are you not in control of that? That's the biggest problem. And can you turn it off, and can you turn it on? So
Yeah, that'll
like
be.
the brain does, and if you look at the eyes in general, it does so many hacky, really, really stupid things that if you told a programmer in simple text what they do, the programmer would go, "Who made this program? Because they're stupid." Like we have little
Right, yes.
buzzing that our eye does, but instead of actually seeing the
Emotion.
blur, it just goes
Yeah.
time scale. Nope, and now you're over here. You didn't even see your
Yeah,
eye
and
move.
each one of these could be a potential vulnerability. Like anytime there's a programming flaw in a program, that's a potential bug or that's a potential vector for attack. So
And
yes,
brain
that
is
is
the
a
biggest,
problem.
like the biggest flawed, most crazy, somehow janked together working
It is.
machine out there right now. To the point of, I think that if, like, to the point of what Vessel was saying, if anyone tries to break, like, your immersion or your brain is going to stop at first. It might not be pleasant. It probably most definitely will not be pleasant at all, but it can recover. It can keep doing its
Alright,
neural processes.
Catapult had a comment.
Yeah, like if it ever gets to that, I can just imagine the advertisements. Why use your eyes? Use our visions and get totally screwed up.
Yeah. Well, for free even, because they're like, we get a free bionic eye, and then they're recording everything that happens in your eyes.
Yeah, well, it's kind of like the movie Total Recall, you know?
Yeah, well, I don't quite remember exactly what
Arnold Schwarzenegger, Total Recall,
Yeah.
where he goes into this place, he wants to play out this fantasy, they hook him all up. He gets into the fantasy, but then can't get out.
Oh, okay. Yeah, that sounds good. Okay, vessel unit and then cat.
All right. I just like how we all just we all expect the worst case scenario dystopia when honestly I feel that like a lot of other technologies that we've had, a lot of the political stuff really gets to the point where people will actually fight for that sort of reason, that sort of purpose for that freedom, and to actually have the security that they will have to be forced to actually fix that. So even if we may have security breaches, it will not be as common, and I really do not think that businesses will actually use our own personal information for that sort of thing, just like how they are currently doing with everything that we do now. Sure, it may be in record where we visit, but they're not going to just collect information on us like that, because that would be very unethical, and humans will stop other humans from doing that, because there are at least some people still with morals.
I got a response. So the thing about the current situation though is that it's not the big companies that own your data. They're not the only ones to worry about, right? Because if they have a bunch of sensitive data, then anybody who can get into that system has access to that data, and then they will weaponize it, and then they will
yeah, and that's literally the only security breach I can think of. Well, not the only one, but that's the main one.
Hundreds of thousands of people have their identity stolen every year. So it's a threat. Like that's something to think about still, even if it's not like the main like how the system is supposed to work. It still opens it up.
Yeah, I mean, privacy will be an ongoing problem for decades to come. Just like today.
Okay.
I mean,
yeah,
it's
because
never
we
it's
have
never
the
gonna
will
stop.
to invade privacy is the problem, but we can't help that.
Okay, thank you, Vessel. We've got Catapult speaking for Sarah, and then Cat.
What about Catapult?
Go on, Cat.
Hold on.
Go on, Cat.
Yeah, it's because I got the dash up, and when the dash is up, I can't use my push to talk thing. Okay, hang on a sec. I'll go take a look again, see if I can memorize what she said. Input is always the shit. Hang on.
No, you got it, bro.
Input is always the largest propaganda machine, regardless of medium. That's what Sarah said.
Is that it?
Input from from like TV shows and content and like that type of stuff.
The stuff we
what
take
we're
in.
fed on the screen.
Oh my god,
I guess I'm not
really
quite
good.
sure what you're. I hope I got the gist of what you're saying. Let's move on a bit. Kat?
Go on, cat free.
Okay, so we're on ethics, right?
Yeah.
Well, I was gone for a few minutes. Had to eat. Let me think. So, I didn't hear what everyone said, but wouldn't a big part of the ethics be for people trying to use it for commercial use? Did anyone say that? Again, I was gone.
Yeah, I mean,
yeah, a little bit like tracking your data in order to
Yeah.
like, someone mentioned extreme advertising.
yeah. I mean, fundamentally, what's going to fund the research to have this tech? It's going to be, you know.
Yeah.
I mean, why did
And, like,
Facebook buy Oculus?
That's kind of scary too. Like if they can read your mind to know like exactly what you're gonna buy, then when they advertise to you, like at what point does it become? I mean, like
A
if they
breach
know
of
the right ways to
privacy.
yes, that and like unfair at a certain point.
And the more data these companies can hold, the more
Um,
leverage.
Yeah, I think the longer that sign like this would be out there, I think someone would finally say enough and have sign to where people would no longer have breaches of privacy because I'm pretty sure there's someone out there that says you have your own privacy and that no one can invade that. So sooner or later, someone's gonna say, "Get out of our heads."
No, I mean, the thing is, it's not about what somebody can say this, say that. You know, it's the world just works the way it is. You know, that's the harsh thing about it. You know, that's just. It's not
you're right.
nice. Yeah.
All right.
Yeah.
Trust me. Trust me. I know more than anyone that the world is not nice.
Yeah.
Yeah, there's some systematic problems for sure. But to continue, this is a report. This is from the BNCI Horizon 2020 roadmap. Now, this was developed in 2015, but it's like basically a map of where we're headed in terms of neural interfaces. And you read about this a little bit, Freeman. Did you?
Well, I haven't seen this diagram now.
Oh, okay. This is from the PDF that they published. Basically, like some of the areas that they kind of estimated back in 2015, in 2019 we already have it a little bit. For example, adoption by users. I mentioned that there was that neural app store that they have available. So that's already starting. And then like brain state monitor, like, you know, I mean, we've had that for a while. I think just a couple of these, like there's going to be quite a lot of movement, I think, in this direction.
Yeah, I mean, I think we should emphasize that this is mostly medical. I mean, because at the end of the day, this technology is most useful in a medical sense first. You know, it's not for, you know, us like game, you know, at the end of the day, because this could help so many people.
Yeah.
I just got something real quick for Sarah.
Okay.
Okay, I'll read it in pieces here because I got to switch back and forth between the Oculus Dash and Steam. Hang on a sec. An open web determines that privacy is entirely based on what you allow.
Well, yes, but then users can be
I wish I could believe that.
persuaded to allow a whole bunch of things, like our entire browsing history is being tracked, and like some of us know about it and some of us don't care, and like you know.
Well, that's the thing. I mean, anyway.
So like, yeah, people are complacent. They like it's biologically, it's kind of a biological imperative to take the easy way out. Like that's why you see that's what the majority of people do.
So
Okay, if that's not what you meant, I apologize, Sarah. But you can come on the Discord if you want to chat about with us more. Freeman, we're okay. So we need to wrap up here pretty quick. But okay, one last comment from Igrium, and then we'll be done pretty soon.
What happens to the first generation that isn't told that having your privacy invaded is bad? What happens to the kids of our kids who grow up in a world where they don't even realize that like having your privacy invaded is a thing, and like to them it's just the norm that everyone knows everything about you? What happens when they reach that point? Then there's no one else to stand up to the madness because they don't know that it's madness in the first place.
No, I think
Yeah, when it becomes the norm.
I never thought of that.
so. Normalization is a powerful force. We see that in places everywhere. We see it in terms of like every heinous crime that you see committed or throughout history. Like everybody's kids was taught that was okay. Like at one point, slavery was just okay because that's just something that you do. Nowadays in China, it's okay to not be able to speak your opinion and to have, it's okay to not be allowed to have any political opinions against the government party because that's just how things are. That's how normalization works, and that's how values spread, and like that is a problem. That's part of the systematic issues.
I mean, yeah, exactly what Popular Post said. It's ideas and thoughts. It's all about spread, isn't it? When what happened. During the war times between the First and Second World War. All these. All these fascism and all these common thoughts. Nowadays, you think, it's ridiculous. How did it spread? Well, people were frustrated with the current, status quo, etc.
And different ideas got normalized, and then it became okay. And then
But anyway, I think we should end it here. I think we've gone a bit over already.
Okay,
so
we have a little bit.
Only gonna happen from here.
No, it's
Okay, to end it up, Freeman.
no. We'll just end. We'll just end it. No, we'll just end
Are you
it.
sure?
Just end it here.
Okay.
Yeah.
All right. Well, well, thank
Stop
you.
fucking out, boys.
Yeah, thanks
you
everyone
for joining us.
Yeah.
Hold on here. I'm going to.
Well,
we're gonna
thanks for having us.
We're gonna get a group picture. So, come on up here and let's take a picture if you'd like to.
Oh, I mean, it's nice to see some new faces, by the way, that I've never seen before. I appreciate that.
Well, Vessel, what do you think?
It was fun being able to talk about this stuff with other people.
Hey.
Yeah.
No, I mean, really appreciate you guys coming.
We'll get you next
Yeah,
time.
I know. I did have too much to say.
No, I mean, it's because I think we started a bit late, so.
Thinking emoji.
New people.
Wingnut.
Newbies.
I do.
Emoji.
Something about the brain. I don't know. Okay,
What,
alright.
zombies?
You got me thinking.
Well, at least.
You got
me
thinking.
So I can say whatever the hell I want and it's not going to change the
No.
picture.
No, it's wrong.
Okay.
No, I appreciate all
Good
the
job,
people
everyone.
who's come.
Thank you.
Yeah.
Thanks
for
I'm so bummed out my video didn't work.
I can't promise I'll be here
Thanks for
often.
having us.
It was
Well, this is
so
the first time I've ever
good.
hosted, so
Can you link
Yeah, but like I can't promise I'll be here
I'm not
often.
the